Today we are going to start a new topic in Software Engineering Unit 5. I've already made my big screen and I will discuss all these points. Here we are going to see something about software testing fundamentals, and that in that one we are going to see white box testings. In that one we are going to see basic part testings, and if possible we'll also go for graph matrix. If I can able to cover this point, I'll able to do this point. Otherwise we will able to see in our next video. But we will be going about started with white box and how many parts are there, we will able to see it. Okay, what is testing fundamentals? What are the characteristics of testable? It is operatable, it's better work, it easy for test, focus on specific area. We need to focus on specific area, dealing with what is the frequent issue and causes. What is the frequent issue? What is the specific area why it is getting crash? That is one. Observe incorrect output. It should give proper output. If it is not giving you proper output, then there is internal error. Controllable ability to specify specific condition and reduce issue. The state of variable. Specific condition. Software can be controlled directly by the tester. Decompose the software, build independent, and all the modules should be test independent. Simple, the program should exhibit all the function structure and code simplicity. Stable, frequent changes can disturb the test, so we need not to leave unreliable testers. Changes in the software should be tested and frequently. Do not invalid existing testers. If you are doing changes frequently, then it will lead to a test. Understandable, the overall architecture is well should be understood and documentation well should be organized. So there are few things about that one. Other than we have got exhaustive testing. Now let's take an example. I have got this statement and they have got about one condition, one condition, one condition and one condition, and there is one more condition. So if the loop is greater than 20 or less than 20x, it's given as less than 20x. If I go all the path, I'm not going which is the possible path. If I go for all the path which I execute, there are 10 to the power of 14 possible path. If you execute one test per millisecond, it will take this many times for the program to be executed. So the rectangle path will be a process, and this is your decision, you know it, and this is a flow control. And if you want to take all the path, I'm going to check this condition, 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 I'm also going to check this. The program what you design has to go through all the paths. Then if all the paths, then we have to go for this one. Now if you go for the selective path, then it's very far easy. And if I'm going for this path, then I'm not going to execute this path. So how I'll be? It's very easy for me. That's why we have to go for all the selective statements. If you have gone through all the programs of C language or C++ or Python or everything. And then software testing is divided into two parts, that is white box testing and black box testings. Method strategies are there. They are divided into two parts. We are going to see in this about white box testings, or we can call it as glass box testing or transparent testing. So don't get confused if they ask you about glass box testings or transparent testings. It is called white box testings. Knowing the internal working, it tell you all the internal process all the internal process and all the specification regarding that one. Involve all close examination procedures. So logical path also, it go for internal operation, path, loop, condition or logical operators. All this will be done in white box testing. It is divided into basic part testing, graph matrix, and in control structure we have got conditional testing, data flow testing, loop testing. So we will be seeing all till what time we are able to see it. Let's see it. Okay, now basic part testing. Basic, why it was introduced by Tom McCabe, is it's nothing but it's part of white white box testing. It was introduced by Tom Mack. Okay, and every statement it used for logical complexity. It is basic set of statement. Every statement, he says that every statement should be executed at least one time, at least one time. Okay, and uses basic set of execution. Every statement should be executed one time, and logical complexity. Graph, flow graph notation, we have got node represent sequence of more problem statement. Node contains simple condition. Node is a starting point and it contains some condition expressed in representation of Boolean values, predicate values, correct? These statements are represent, it has a node with starting point, a sequence of statement, and which has got some condition. In that condition contains some Boolean values. Each component condition Boolean values, and it has got two edges, correct? And it has got two edges, and the edge is a link which represent the flow of information, which must start and which also must end, correct? And it cannot interact with crossover things. Area boundaries are inside the region and outside the region also we have to see it. We will see with the help of an example all those things, correct? Then we have got cyclomatic complexity, which is represented by Vj. Provide quantitative measure of logical complexity. It's defined number of independent path. All the statements should be executed one. It provide upper bound, and all the statements should be executed at least one. It has got three ways. Vj is equal to e minus n plus 2. Way is the number of edge, n is number of nodes. And again Vj plus p plus 1. P is nothing but how many logical operators are there. Okay, how many logical operators are there. So cyclomatic complexity is that Vj is equal to e minus n plus 2, correct? And where e is the number of edges and n is the number of nodes. Now for an example, let's say this is a basic path of testing. I have got a program which is represented that one. Here cyclomatic complexity Vj is equal to e minus n plus 2. Now e 10, which is represented with red 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have to take into this 10. So it is represented 10. And how many nodes are there? 1, 2, 3, 4, 5, 6, 7, the endpoint, plus 2, that is 4. Number of region, it has to count the outside also. This is R1, this is R2, this is R3, outside region also there. And conditions 1, 2, 3. P is condition 1, 3 plus 1 is equal to 4. So what is this one? Here cyclomatic path for above region is Vj is equal to 4, number of region is 4, and more importantly conditions are this one. These are the formulas which I have to take into this consideration, correct? And now cyclomatic concept. If this is more, we have got more number of error. If it is less, we have got less number of error. If the cyclomatic is increases, we have got the condition that it is contain more error, where here it contains less error, correct? And a path of testing, if you specify we are going to go this path, it's very easy for us. For a part, we don't need to flow chart, put the picture with the help of a trace program. Count the number, simple logical test, basic path testing can be able to do it. If you know which path we are following, we can able to do this path. Flow graph, this is your flow chart and this is our flow graph. If you go through it, I have got how many? 14 edges. 14 edges and 12 nodes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So started with 0, we have got 12 nodes. For region R, where is this R1? Probably this is R2, this is R1, and this is R3. Outside region is 4 region. And then adjust, if you count it, it will come to 14. So this is our flow graph. Now, if you come, if for the equation, if you go at number of region is Vj of edges 14, that is 4, region is this one, as per this graph. This one, this is how flow graph is being used, and this is how it is being done. Other path, we have to go for independent path. Independent path, we have at least one path. The diagram which I have just taken it, independent, at least each path. Every time, at least a new path or a new node has to be traversed. At least one edge that has been not traversed. When you take it, every time new things, at least one edge that has been not traversed. Basic path for previous slides, which I have taken a graph here. Path 1. Path 1 is 0, 1 and then 11. This path 0, 1, 11. Path 2 0, 1, 2, 3, 4, 5, then 10. That's path. And then it will go to 11 again. Path 3 0, 1, 2, 3, 5, 7, 9, 10, again it goes. So every path, this is our basic path, and number of path is a basic set determine the complexity of that one. This is independent path. Driving the test cases, basic set, using the design of code and foundation, draw the corresponding flow, determine the cyclomatic complexity, determine the basic linear independent, prepare the test cases based on that one. Correct? Hopefully. And then we have got about this condition which is available here, a simple function diagram analyze. I have got 3, 4. The program is here. 1, 2. We are not taking it. 3 into 0. Then we have got while condition which is represented here, and while x is greater than y into y. Correct? If we have condition 4, x is percentage d and x this, and then printf so and so, then it will go up. Whereas here, if I have got else if, then I'm going here. This is become else. This is else if these are all conditions here. And then 6, if x is mod, if this condition are not satisfied, what I'm going to do? Where I'm going to do? Print percentage d 9. Where is 9? Print this one. If condition is satisfied, I'm coming to 7. This is what? 7. And then I'm going to print this statement, and then I'm going to 10. After that one, I'm skipping this one, I'm speaking this one, and skipping, then I'll come to print 18 statement. After 12, if my condition is satisfied here, then I'll go to 13. Then after 13th, I'll come to 18. So this is the path we have got. Simple flow of graph. So we will stop at graph matrix and we'll continue in our next video how we are going to do it. Okay.